Hello and welcome to TidyX episode 104, TidyX's screencast where we go through and explain how our code works. My name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick and at Tidy_explained is where we both reside on Twitter. Tidy.explained at gmail.com is where we both reside on Gmail. You can always go to the GitHub repo and take out an issue, but the most typical way people get in touch with us is via the YouTube channel, liking and subscribing and dropping a comment, which we will be going to that mailbag today to deal with a comment. And if you enjoy our work, you find it useful and helpful to you, and you'd like to support us in any way, we do have a Patreon page, and we appreciate all who have contributed to this point. We appreciate that greatly.
Yes, exactly. Thank you all so much for becoming patrons and just commenting, subscribing, liking. We appreciate hearing from you all, making sure that we're providing content that is useful to you because we want to make R approachable and fun. And so so we got a comment a bit ago asking us about dates and lubridate. And so we figured this is an opportunity for us to maybe go over a little bit of objects and discuss that. If that's a topic that you'd like us to go into more detail, please leave a comment down below on like the next object type you'd like to see us go through. So I will share my screen. Patrick, do you have anything as we're going through this transition?
Dates are super confusing in programming languages, whether that's R or Python. They get me every time. But it is super important because, especially if you're working with like tracking data, GPS, accelerometers, inertial sensors, sleep trackers, basically anything that's time stamping us by the seconds or minutes or fractions of a second, depending on the sampling rate of the system, force plate data, all of that kind of stuff is going to come with a column. And that column is usually some sort of string, combination of dates, minutes, and seconds. And deriving the meaning from that column and the difference in time between each row, which is usually some sort of observation, is important. And dates are really confusing. So it'll be good to kind of go over what this stuff is. And maybe if people like this episode, we can pull some raw data and look at what dates look like in the wild, so to speak.
Exactly. Yeah, so before we get into dates, I wanted to touch a little bit on R and the object systems that exist within R. So R has several different object system types that exist, and these are systems, not the actual object classes, and so that can get a little bit confusing. So R has several different systems. So first there's like base. So base are these base object types that are defined. They're like core to nearly any language. I think those are like integers, numeric, booleans, null. So objects that we are not going to be changing behavior of, right? Like this is defined like in the core code, source code of R, right? Then there's an S3 and S4 object systems. So S3 is a fairly flexible object system where you define this is what an object will have in its contents, and then you define a series of methods, and that's pretty flexible that when you run a function on this object of this class, here's how it's going to behave. S3 is found in a lot of R packages. I know all the R packages that I've created custom S3 classes. They're super easy to work with. That's like my preferred object system. S4 is a much more strict version of S3, I believe. But S4 is really found commonly in like bioconductor and those sorts of packages. If you don't work in bioinformatics or that sort of world, you may not have heard of S4 object, and that's perfectly fine. Just know that it's very, very defined how behavior, and you need to think a lot about design ahead of time. S3 is a lot more, you figure it out as you go. R6 behaves very similarly to like Python or Java classes where you need to define the contents as well as the methods. And then it moves through states. And so it it's not like you define it and then get a copy of it over here and then you can do whatever you want and it doesn't impact the original one. It stays with it. It's kind of confusing. If you want to learn more about that, let us know. Leave a comment. RC is similar to R6 in my opinion, in the way that I've used it. That doesn't mean it's the same. It's just the way that I've used it. And then R7 and beyond, like there's groups of people that are looking at additional object systems that can exist. There's like an R consortium group that's looking at that. So just know that like this is kind of an ever expanding. People are still figuring out how like maybe the best system or the best system for the problem that you have. If you want to learn more about object systems that exist inside of R, Hadley Wickham wrote a great chapter on this in his Advanced R book. The link is right here, Advanced R, hadleynz.oo.html. And if you want to learn more about this topic and then ask some questions, that is a good place to start with. So that's a little bit of background on that. So now we're going to talk about the date objects themselves, and because I felt like that primer on objects was important to understanding how date objects themselves operate. And so there's three different types of date objects you can find. There's the date, which is the dates that you have. There's POSIXt CT and POSIXt LT. Date objects and POSIXt CTs are the ones that we're going to talk about in this video, because those are the two that I work most commonly with. I don't think I've ever really worked with POSIXt LT type classes really, and if you have, I've just converted, if I've come across them, I've probably just converted them to POSIXt CT type objects. So the difference between date and POSIXt CT is date is only going to have the date, so year, month, day information. POSIXt CT has information like sub-second information that you've gotten. So we'll get into that in a sec. Sorry, date objects. So if you're going to be creating a date object, one likely way you'll be doing this is you've been given a vector that's got these character values that have the year, month, and the day, and you want to now work with these as dates. And so the simple way to do this, like if you've read in a CSV that has a column of dates, you can just call as date on them. And then if they're formatted in a nice ISO date or very clearly able to define which column represents the year, month, and the day, it'll convert it happily, nicely, has no issues with that. As you can see down here, it's now converted this into a date we can call, but if you have an awkwardly formed string, so maybe it's like 2022-01, it's not really going to know what to do with this. And so that is like the downfall of just calling as date on a character vector, is this formatting needs to be correct and accurate. But what is a date? What is under the hood? I know when I print this, it gives me like this nice string here, but this isn't actually what the information that it's holding under the hood. And so if we call dput on date, so dput is a function that gives us the underlying structure of an object. It's actually giving us this number, 18993, of class date. And so this is what our representation of a date is for us. And so this number here actually represents the number of days since the origin in R. So the origin is the date at which we say, this is day 0. Mm-hmm. And we've talked about this in the past, I believe, in our spreadsheet cleaning series, where the origin of R is 1970-01-01. So January 1st, 1970 is day 0. And then any day after that is represented as a positive integer, and any day before that is a negative integer. And so we can also create dates by passing in a number into the as date as well as the origin. So what day do we reference as day 0 for this purpose? And so we can call as date 0, setting the origin to be January 21st of this year. Well, January 1st of this year. And we see there, boom, January 1st. But we could also pass last year, January 1, and pass 365. So it's been 365 days since this origin. And we'll get the same date. because it's converted it under the hood. If we want to look at the values that are actually held inside of those objects, we can see that these are actually all 1899.3. So it's been 18,993 days since the origin. R under the hood converts everything to use the same origin, which is 1970, January 1st.
Yep.
So that's kind of like, once you wrap your head around the idea of what's contained in a date isn't the actual string that you passed or the number. It's actually just a simple number representing days since January 1st, 1970. You can kind of start to figure out how you might be able to use that to your advantage. And so we can, just to demonstrate this again, we can call asDate 0 days since that origin, and set the origin to be 1970-01, and then convert it back to a number. Sorry, that's like moving forward and backwards, but as you can see, it's 0. So that's the date. One thing to note too is if you're working with dates that are in Excel, if you've read an Excel file and you've got a column of dates and they're now numbers, the origin that Excel uses is January 1st, 1900. But it sets that to be 1, I think. And so in R, if you want to use that, you have to set the origin to be December 31st, 1899. And it'll then convert it properly into So dates can get confusing and weird. I just wanted to bring this, I wanted to talk a little bit about how you might use this. Okay, so that's a date object, and that only contains month, day, year information. Well, functionally days since that. There's no sub-day information that's contained in that. And that's where POSIXt CT objects come into play. And so they represent the number of seconds from the origin of 1970-01. The benefit of this is it allows for sub-day units. So this allows you to even pass milliseconds. I put milliseconds out here. You can go down to picoseconds. It's a true numeric value. So you can see, you can get as fine of a timing as you can reasonably measure with POSIXt CT. Some of the confusion that can actually occur with POSIXt CT is now there's time zones involved, because we're now dealing with time information. And as we know, time information has bias. Bias maybe might be the wrong word to use, but bias in the fact of where you're measuring it impacts the time that you say it exists. And so we as humans have created all these time zones to make it easier for us to know how to, live in our world. But that then adds a lot of confusion into how to deal with date time information. And of course, it doesn't help that, we have spring forward and fall back, daylight savings and whatnot. And then there's some areas where time zones are 30 minutes ahead. It just gets confusing and difficult. It's hard to come up with a good way to do this. So thank anybody that works with date time information and give them a hug. And then the other partial issue is with, now that we have this time information, there's a lot more richness of information that we can gather from this. So just kind of keep that in mind. But to create a POSIXt CT function similar to the date, we can just pass a string or a vector of strings, but it needs to be formatted nicely. So it needs to be able to clearly identify what the date is, the month, the day, the hour, the minutes, the seconds, the AM or PM potentially, and the time zone. Doesn't need all of this information all the time. You could get away with this. But it's then going to have to start making assumptions as to what the actual time zone is. Is it AM or PM? It's going to probably assume AM and assume this is a 24-hour clock. But just kind of know that ahead of time there's a lot more nuance that you need to deal with. But we can call DateTime, and now we print it out again. A gives us the correct format that we're looking for here. If we call as numeric on this, we'll see big number. So this would be 1,641,052,801 seconds from the origin. So we can also call dput on there, and as you can see, their structure, they've got the the number of seconds there. They've got the class, so it's POSIXt, and then I guess there's another subclass, POSIXt, and then a time zone entry as well. So this is why everything matters and why we have so much more information there. And then if we wanted to get cheeky and figure out the number of minutes that have been since the origin, because we know this is seconds, we could call as numeric on the date time and divide by 60. And now we know that it's been 27,350,880 minutes since the origin. So I don't know. Do with that information what you will. We thought it was kind of maybe fun and interesting to add in there. But just like dates, you can provide a number that represents not days but seconds. The origin is the date or the time that it needs to start. The time that it needs to start counting from. And then it can also get confusing with like time zone manipulation. And so we'll run these two really quickly to show how they are the same, but then they can print out to be a little bit different with a slight modification. So we're saying it's been 0 seconds from this origin that we're defining. Similarly, here we're going to say 365 days, because we need to convert this into seconds, and we want to say a year has passed because we're going to set this we wanted these two times to be the same, and if we set this origin to be 1 year ahead, we need to make sure this entry here is 1 year of seconds. And so we have 365 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. So if we run this, and then we run these two here, hey, we get the same time, so that's good. Mm-hmm. But what can get confusing is if you pass a time zone UTC and you just run these two again, you can see that we actually end up with different times. And that's because now we've set this time zone argument to here. And so now this is going to say, I actually know this is midnight, January 1st, 2021. But here, when you print this out, it's going to use my computer's time zone. And that I'm in Seattle, so I'm Pacific time. So it's actually going to set it to be, and we're minus 8 hours from UTC. And so that's going to set it to be December 31st at 1600, which is 8 hours back. Mm-hmm. So fun stuff. Gets very confusing if you don't know that the way that it prints changes based on the time zone that you've passed to this, and then you're trying to do manipulations on this later on. It can get confusing, and so just it's a thing to look out for, I think, when you're working with times and dates. Okay, so that's like a quick run through of how you deal with like dates and date times and whatnot, and that's confusing and scary and not fun to work with. So of course the folks at our studio, Mr. Hadley Wickham, is of course trying to make our lives easier and has created a package called lubridate for us to handle date and date time type classes. So he's provided this wonderful package. There's a cheat sheet which is available. I know I referenced this a fair amount. I definitely referenced it while I was creating the today's episode, kind of going through all the different functionality that they've put into lubridate. So if you want to, we're not going to cover all the functionality. There's way too much, but I wanted to like top level a couple of these functions here. So we're going to call library lubridate. And so now we can access and start using lubridate. That's fun. And now one big thing that lubridate that I use all the time is parsing helpers. Because parsing date strings can be really, really frustrating. So say we're given a date string that looks like this. So it's 2011-06-04. Our brains see that as, well, obviously that's 2011, June the 4th, right? Mm-hmm. Like that's, but if we try to throw that into an as date, it has no idea what format that is. It doesn't know how to parse that. And so if we're doing stuff in just base R, we need to tell asDate how to process that. And that's what you use the format argument for. And then you pass the string here. But how do I know what I need to be putting here? Because that's confusing. It's like %y, %m, %y. Where does that come from? So what you do, or the way that I typically work, is I do $strp time. And this is a handy little reference for me. If you scroll down into the details, they've got these formats. And these are, this is like not R specific. This is general programming. These are % and then some letter. And it's a case specific, that this is how you tell the format of this string here. And so what %Y means is there's going to be 4 year digits. %m, lowercase m, says then there's 2 month digits, followed by %d says there's 2 day digits. And so %d, day of month as a decimal number, 01 through 31. So that's what I drop in there. And so now when I try to parse this, it'll give me the correct date. So we're happy, we're able to move on. But that was annoying because I needed to go over into strip time. I needed to figure out, okay, I know my monkey brain tells me that's year. I need to figure out, okay, I need to find in year. All right, okay, so this one is G, last 2 digits in the we space based on year. No, that's not right. So I had to go through here and figure this out. Lubridate has some very nice helper functions that'll handle that for us. There's the YMD function. So this says the format of the string you're entering is based first on year, then month, then year, then month, then day. It'll parse it for us. It's happy and it's correct. The nice thing about this too is there can be other delimiters in there. It don't care. It is able to handle the slashes, the dashes. I believe it can handle the spaces. It's able to handle it for us. Not a problem. There are other functions for parsing dates as well. There's month, day, or MDY, which says the order of the string is month, day, then year, or DMY, so day, month, year. But these
super important if you're working with people in the UK or in Australia.
Yeah, I tend to write year, month, day now. Like I think that like logically makes sense in the largest to smallest. I mean the month, day, or day, month, year. I also see people do as well. We in the U.S. are weird with our month, day, year.
Yeah, totally.
I fell for the argument of smallest or largest to smallest time, but I like that. But yeah, so like these functions I find are incredibly helpful. And then similar type of idea for DateTime as well. So if you were given a string 2011-0604 103000, right? This format here. If you're to convert it into a POSIXt, so you keep this date or this time for information here, you format and then you have to put in the exact structure, not just for date, but for the hours, which is a capital H, minutes, which is a capital M, and seconds, which is a capital S. And then you also have to specify your time zone if it's not included in here. And so here it's able to convert it. Yay, we get 1030 UTC. YMD HMS is able to handle all that for us automatically, no problem. Move on with your life. There's similar functions that exist in lubridate for the different combinations of order you might see, but I just like how much easier it is to use the lubridate function as opposed to me having to define this full format. The next benefit that I find with lubridate is handling time differences and intervals. So we're going to create a couple of different dates here. So first it's going to be January 1st at midnight, January 1st, 10 seconds later. Remember, we're working with POSIXt. And then we're going to do January 1st of 2021, 10 seconds into the year. So in base R, the way that you get the difference in the two times, if you wanted, why don't we quickly go what somebody might think they should do first, which would be just to do a subtraction, right? You could do that. That's confusing. There we go.
There you go. I was going to say, what happened there?
So it's going to run, it's going to calculate and give us a different time of number of seconds. The issue with just doing that is if you have then a larger time difference. So now, as opposed to just being 10 seconds, this is just under a year, the units change on you. And that can be confusing. And so, but what under the hood, what's being called is this diff time function. And that takes the first date, the second date, and then units. Default, this is auto, and so it'll change based on the difference. But if you wanted to have a specific difference unit so that you can use later on, you specify units. And so here I want to know the difference between date 2 and date 1, which is only 10 seconds, and the units I want is minutes. So we can run that, and that's 0.116 or 0.1666 minutes. We can confirm that, divided 10 seconds by 60 seconds in a minute. There you go. It matches. You can also set the units to be whatever you want. Days, seconds, whatever makes sense for your situation. This is all base R. Then if you wanted to get the actual number out of it, you have to call as numeric on that difference there, and you'll get it as 10 seconds. You can try that there, but as you can see, it's inconsistent. This is now number of days, and this is number of seconds. So that's why you maybe don't want to do that. With lubridate, they have it's a two-step process, at least that's what I've been able to determine, where you have your interval, which is the interval. It'll give you this interval object, which is saying between these two times. And in the cheat sheet, it shows a bunch of different ways you can use intervals. You could look to see, like if you have two different intervals, you could see if there's any overlap between those two intervals and whatnot. So there's a lot of cool stuff you can do with intervals. But if you wanted to get duration, you call as duration on this, and they'll give it to you in seconds. That's a nice thing. All right, so there's two more things. Thank you for sticking with us for this. There's a lot to do with dates. But if you wanted to add or subtract time, so say you knew you wanted to start manipulating the time space continuum, let's first create our date one. But when you're doing this algebra and like adding to it, what matters is the object class that you're working with. So here we have a POSIXt CT, right? And it's midnight on January 1st. If you just add +7 to a POSIXt CT, that's going to add 7 seconds. So we run that. Now that's January midnight +7 seconds, Pacific Standard Time. But if you're working with a date object, so we're going to convert this with an as.date into a date object and add 7, that's added 7 days. And if you didn't realize that it was a date as opposed to a POSIXt CT, that can have massive changes in what you're actually doing to the function itself. If you wanted to try to match the 7 days, you'd have to then, to the POSIXt CT, you'd have to do 7 times 24 to give you, times 60 times 60 to give you number of seconds that are in a week. So then add it, and then they match. So those are like things to be aware of. Lubridate makes this a lot easier with their duration series of objects. And so you can do date 1 plus duration of weeks 1. So this is saying I want to add duration of 1 week to my date 1, which is POSIXt CT. It'll run that, and it's given us the correct, it's added 1 week to it. And we can use the same sort of logic for date objects as well. As you can see here, it's added 1 week of duration to our date 1 when it was converted into a date object. So there's a whole series of durations that exist in lubridate. So it goes all the way down to picoseconds. If you're really that finite, to milliseconds, to seconds, to d-minutes, months, years. So it spreads the gambit of realistic times that you could be working with to be adding there. And so that's like, I think that's like incredibly valuable. So you don't have to remember what unit or what object class am I working with, and therefore how do I need to convert it. If you just do plus d week 1, it'll add 1 week. week 2, add 2 weeks to the date object time. And finally, when you want to print things out, this is kind of fully base R. Once again, we rely on our strp time information over here, but you call format on your date and you specify the formats here. So this is going to print it out as 4 year digits, 2 day digits, 2 month digits with dashes between them, a space, then hours, minutes, and time zone. So we'll run this real quick. You can see 422 hour, minutes, time zone. But if you use lowercase y, this is different because remember, case matters. And so now this is going to be the last two digits of the year. And so that can impact how you interpret it and how you use it later on. So like keeping that in mind, and it can look correct sometimes. Like for example, because we have January 01, if you switch up the day and the month and you don't realize it, that can be confusing. So there's a lot of different like nuances to pay attention to when you're working with dates, where it's not just how do I do this once and then you move on with your life. You have to keep track of what units am I working with, what is the order of the string that's coming in, and how to handle that, which is why I think most of the time we just convert it into a numeric value under the hood, set some origin, and move on with our lives. But yeah, so that's kind of a crash course in how you handle dates. If there's a question you have about dates that I didn't answer, which I'm sure there are, leave a comment down below and we can try to address that in a future episode. If there's another like object type that you'd like to see us talk about, and if you have any specific questions about that object type, leave a comment down below, tag us on Twitter, send us an email so that we can try to make sure to address that. Patrick, do you have anything to add to that?
Nope, that's a pretty good overview of dates. I mean, there's a lot there, and it does get really annoyingly complicated at times, especially when you're pulling data from different data providers, because again, depending on if it's a provider that's from Australia or the UK, they might have day and month changed from what you're used to and all that kind of stuff. So it's just a lot to pay attention to, but it is tricky.
Yeah, exactly. Yeah. But I guess with that, we'll call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick and at Tidy_explained is where we're both on Twitter, and tidy.explained@gmail.com is where you can find us on Gmail. You can open an issue on the GitHub repo, or you can like and subscribe on the YouTube channel and drop a comment down below. And again, as always, if you find our work to be useful and beneficial to you and you want to support us in any way, the Patreon page is there down below.
All right. Thank you all so much for joining us for 104 episodes. Keep on exploring your world.